This is a comparison of two computer vision object detection projects. Both control devices connected to one of my desktop computers. One project uses a Raspberry Pi 5, controlling a robotic hand. All code runs on a Raspberry Pi without GPU acceleration. The other uses Google Cloud software controlling LED strips on a Raspberry Pi Pico on my PC via browser and Wi-Fi. It runs Python and JavaScript code with GPU acceleration. Both projects use YOLO computer vision object detection software. First, I will demonstrate the cloud-connected project. Then, I will demonstrate the Raspberry Pi project, controlling a robot hand. Finally, I will compare the features and performance of the two projects and present my choice. This project used cloud-based AI computer vision software on Google Colab that was connected to my PC hardware. I use a Raspberry Pi Pico W on my PC with a Wi-Fi connection to link it to Google Colab on the cloud through a browser. Object detection and recognition were performed with YOLO software on Colab. The Google Colab Cloud platform leveraged GPU acceleration to enhance processing speed. 5 target objects out of 80 predefined by YOLO were imaged with a web camera. These were a fork, a scissors, a mouse, a bottle, and a keyboard. The Raspberry Pi Pico W microcontroller on my PC controlled LED strips. Detected objects surrounded by bounding box send the name and confidence level to my Pico W. When target objects were detected by YOLO, the corresponding LED strips were triggered on. Here is a recording of the live detection of 5 different objects as they are placed or removed from my camera's view. Notice that detection of an object turns the LED strip on, and removing the object turns it off. Computer vision object detection, controlling a robotic hand with Raspberry Pi 5. My hardware setup includes a Raspberry Pi 5, a Pi Camera 2, and a robot hand. The robot hand with servos is connected to Raspberry Pi GPIO pins. YOLO real-time object detection software receives video streams from Pi Camera 2. Detected objects surrounded by a bounding box show the name and confidence level of the detection. YOLO has 80 pre-trained objects. I use 4 of them. My detected objects trigger corresponding fingers of the robot hand to point to their labels. Objects that I did not specify don't trigger actions on the robot hand. I chose a larger YOLO detection model, S, versus the smaller model, N, to detect smaller objects like the fork. This resulted in a slower video frame rate of 4 FPS versus 10 FPS for the smaller YOLO model. All Python codes were executed on a local Raspberry Pi 5 without a graphics accelerator. Here is a real-time demonstration of object detection. 1 or more 4 physical objects on the right side of the screen is detected. This triggers an action on the robot hand via the Raspberry Pi 5. The fingers point to the corresponding label of the detected object's name. I will compare two projects and evaluate their strengths and drawbacks. One uses LED strips and coding on Google Colab, and the other uses a Raspberry Pi 5 with a robotic hand. Here are the pros for the LED project. Here are the cons for the LED project. Here are the pros and cons for the robot hand project. My choice is the Raspberry Pi project. It has all software and hardware on a single device. It has sufficient speed to detect my objects and activate the robot hand.